So welcome, this is IBDP paper AHL TZ1 paper 1 from May June 2022. Question number 1 to 8 are being solved in 4 parts. This is the 5th part. Consider the complex number z1 equals to 1 plus bi and z2 is 1 minus b square minus 2bi, where b belongs to R. Find an expression of z1 z2 in terms of b. So z1 z2 equals to 1 plus bi times 1 minus b square minus 2bi. So now what am I going to do that? I am going to multiply this one carefully. 1 plus bi times this one. So I want real parts together and imaginary parts together. So 1 times this one is 1 minus b square. Then I think so bi times this one gives me minus b2b square I square. So those are the real parts. Now I need to figure it out. How do I get the imaginary parts? 1 times this one is going to be imaginary part and bi times this. So bi times 1 minus b square is an imaginary time, and 1 times minus 2bi is going to be an imaginary part. So if I simplify and write, it becomes 1 minus b square plus 2b square, then I common. So b minus b cube minus 2b. So finally I am going to get it out 1 plus b square, then plus I common minus b cube. That's going to be the answer for expression of z1 z2 in terms of b. Hence, given that argument of z1 z2 equals to pi by 4, find the value of b. So argument of z1 z2 is nothing but what? Tan inverse of imaginary part divided by real part. This should be equals to pi by 4. So bring tan to the other side. Tan pi by 4 equals to minus b common 1 plus b square upon 1 plus b square. 1 plus b square, 1 plus b square cancels, and tan pi by 4 is minus plus 1. So minus b equals to 1. So b equals to negative 1. That is question number 9. Now question number 10 is a big question from section B. So over here we start a new page and try to solve it out in a proper way. So only first question will solve, then we'll go to the next video. Now what is that? Consider the series ln x, p ln x, 1 upon 3 ln x, and so on. Consider the series is geometric and prove that it is a, and show that p equals to plus or minus 1 upon root 3. That is being asked us to prove. So part A, what is the sequence? Ln x plus p ln x plus 1 upon 3 ln x plus and so on is this one. Now consider the series is geometric. P equals to 1 upon 3. So T2 by T1 should be equals to T3 by T2, should be equals to the common ratio. So we can see that this is first term. Instead of T2 and T3, as in the formula booklet we have written it out, U2. U2 upon U1 equals to U3 upon U2, so that you don't get confused. So this is U1, this is U2, and this is U3. So P ln x upon ln x should be equals to 1 upon 3 ln x upon p ln x. We can see that ln x, ln x, ln x, ln x gets cancels. So p equals to 1 upon 3 upon p. Cross multiplication. So I'll be getting it out. P square equals to 1 upon 3. P equals to plus or minus 1 upon square root 3. That is the first part of the question. Now, hence or otherwise, show that the series is convergent. To show that the series is convergent, what is the condition? What is this? Absolute value of p is 1 upon root 3, and which is less than 1. So for convergent, it should be lying between negative 1 and positive 1. So therefore, it is converges. That is a condition. Next, given that p is greater than 0, show that s infinity equals to 3 upon root 3. So, s infinity is u1 upon 1 minus r. u1 is ln x upon 1 minus. Now he has told that p is greater than 0. So, out of plus or minus 1 upon root 3, I take only positive 1 upon root 3. So, it becomes, what does that becomes now? And what is he asking us to show that? And s infinity equal to 3 plus root 3 equals to 3 plus root 3. This should be equals to 3 plus root 3. So ln x divided by root 3 minus 1 by root 3 equals to 3 plus root 3. So I do the cross multiplication. So what do I get from there? I add a page there. So it becomes ln x equals to 3 root 3 minus 1 by root 3 times, if at all I take root 3 common, root 3 plus 1. From here, if at all I take root 3 common, root 3 plus 1. So that what will happen is, easy to simplify, root 3 gets cancels. A plus b times a minus b is a square minus b square, which is going to be 2. So ln x equals to 2. So x equals to e square. That's going to be the answer. Next one, now consider the case where the series is arithmetic and the common difference. Show that p equals to 1 upon 2 upon 3. This time it is a arithmetic sequence. So for part B, u2 minus u1 should be equals to u3 minus u2. So p ln x minus ln x should be equals to 1 upon 3 ln x minus p ln x. So what does that becomes now? 1 upon 3 ln x equals to p ln x minus ln x plus p ln x. So 1 upon 3 ln x equals to 1 upon 3 ln x plus ln x equals to 2p ln x. So 4 upon 3 ln x equals to 2p ln x. Ln x cancels, 2p equals to 4 upon 3. So p equals to 2 upon 3. That's going to be the answer. Next, write down d in the form of k ln x, and the sum of n terms of the series is 1 upon x ln 1 upon x cube. Find the value of n. So we have to find it out the common difference now. For part 2, we have to find the common difference. Common difference is going to be u2 minus u1, which is u2 is p ln x minus p ln x minus ln x. P ln x is 2 upon 3 ln x minus ln x, which is minus 1 upon 3 ln x. That is the common difference. Now finally, he gave the sum to n terms is ln 1 upon x cube. So part 3, Sn equals to n upon 2 2u1 plus n minus 1 times d. So which is ln 1 upon x cube equals to n upon 2 ln x plus n minus 1 times minus 1 upon 3 ln x. So this is ln x to the power of negative 3 equals to ln x common n ln x upon 2 minus plus n minus 1 times negative 1 upon 3. Then minus 3 ln x equals to n ln x upon 2, then 2 minus n minus 1 upon 3. Ln x and ln x gets cancels. Negative 3 equals to n upon 2 times 6 minus n plus 1 upon 3. So 2 times 3 is 6. 6 times 3 is negative 18 equals to n times 7 minus n. So negative 18 equals to 7n minus n square minus 7n minus 18 equals to 0. N minus 9 times n plus 2 equals to 0. You get n equals to 9, n equals to -2. But n cannot be negative, so therefore n is equal to 9 is going to be the answer. So that's going to be the answer. See you in the next video. Bye.